So in fact, I can look at this two ways. I can calculate, so what I was initially going to do was I was going to calculate the total number of symbols that can be sent, and then divide by the number of users. But I think it makes more sense to calculate the amount of time that each user gets as a fraction of the frame, and then we can multiply by that to get the fractional bit rate. So there's a total of 9.5 milliseconds of useful time. We divide that evenly amongst the users. We get 1.9 milliseconds per user. So each user gets 1.9 milliseconds divided by 10 milliseconds per frame. So the fraction of the available bandwidth that the user gets should be 0.19. So each user gets the available bandwidth for 0.19 of the time, and so therefore the symbol rate for a user should be this times that. So how does that work? Time is divided into slots. Each user gets a slot, and gets the full resources of the system for this fraction of the time. I have to subtract the guard band, that's what I did here, and then I calculate the fraction of time, fraction of the available time that the user can transmit. And then all I need to do is multiply that. That's the fraction that the user can use. These are the available resources. So the available resources per user is this times that. Okay, the other way to share resources, the other obvious way, is called frequency division multiple access. Basically, there the philosophy is each user gets a fraction of the bandwidth all the time. So in other words, I'm going to take the available bandwidth in the frequency domain, divide it up, and give each user a chunk. So here's an example. So here's my available bandwidth, let's say. And I have 5 users, let's say. So there's 5 equally sized chunks. And what I'm going to do is I'm going to allocate each chunk to each user, but there's going to be a guard band built in. So basically, each user gets the total band minus the number of users times the size of the guard band, BG, again divided by the number of users. So in some sense you could also write this as, by the way, this is the useful bandwidth, and I divide that equally by the number of users. So I can take out this and write this as equal to available bandwidth divided by the number of users minus BG. Or this is BG in here. So other than that, the analysis is exactly the same. So there's an available resource. So here it's bandwidth. In the other case, it was symbols per second. There's a bit of waste. Here it's guard band. There was guard time. And there's a number of users to allocate that over. A couple of questions. Why have a guard band in here? So timing jitter was the problem in the time domain. Here, there's two things. Firstly, there can be frequency jitter. Oscillators are not always at a precise frequency. There's also, if this is a mobile system, there's the Doppler effect. So if I'm driving towards the antenna, then I will shift up a bit. So I need a guard band to protect against that. The other question is, okay, so in both FDMA and TDMA, this is great as long as you need that bandwidth all the time. So what if you're doing packet data? So in packet data, you send a request, the request comes back, and your use of the resources is very sporadic. So here, let's say you want to set up a packet data connection. You send a packet, you get a slot, you send some packets, then you sit idle for a little bit waiting for the response, then you get the response. So in cases where use of the bandwidth is sporadic, this is actually very wasteful. So it requires a lot of effort on centralized control to set up. And if you're not using that resource all the time, this is not a very efficient way to allocate resources. So on Tuesday, what we're going to talk about is spread spectrum, multiple access. And basically the idea there is we tolerate a little bit of interference. In other words, here we rigorously try to keep the users apart into their own separate little spaces. But in spread spectrum, we allow them to overlap, but the exchange for that is that there's no need for centralized control. And if a user isn't active all the time, then it doesn't really matter. We can actually exploit that. Okay, any questions?
For band division multiple-access, so where's it being used? Can you give an example of the usage for band division multiple-access?
Yeah, have you ever heard of GSM?
Yeah.
Yeah, so that's time division multiple-access. These kinds of, fixed resource allocation methods, they do really well in phone, in telephone applications, because there, you set up a phone call and it's there, that phone call is there for like half an hour. So there you're constantly using the resource. In fact, GSM uses both FDMA and TDMA in different processes. Any other questions? Great to see you.